All right, so let's take a look at, let's see. We have, this is the original ball that we talk about it. And this is a lonely ball, I call it. It's by itself. And then I have a second version of ball in which, and this is one design, there are other designs, by the way, in which I have, well, first of all, I changed Rx and Ry to be different than 0, so it wouldn't get trapped in the collision detection. I created a whole bunch of getter methods and setup methods. The reason why I did this is because I am going to need that information from another ball, so I can handle the collision within the class itself. So those are my getter methods. I get the location, the speed, and the radius for a ball. Then I have the setup methods if I want to change things about the ball itself. And this is going to be very handy when I have an input argument of an object of ball. This is nothing new. We did that in the last version of the bouncing. So far, as you can see, this is the same thing. These 3 methods over here. So I created a new method, a new move method. When you create another method with the same name, but different argument list, that's what we call overloading. So I have overloaded the move method for more than one ball. Let me rephrase that. Method to accept another ball. To accept another ball. No chess. So this ball class is handling itself, and as an input, another object of the same class. And here it is. Here's the name of the class. That's the abstract data type, or ADT, that's what we call it. And this is the name of the object. It's also a variable. So because of the way I design ball, I have access to information about anything that comes in here. Remember, it is important for encapsulation that your instance fields are private. I'll be looking into that because this is part of what we learned not too long ago. Encapsulation requires that the instance field should be private. And that's why we need getter and setup methods. So if I go down here to the new move method that actually takes one argument, and one input argument, and is nothing more than another ball or an object of ball, in this case ball 1, because it's the next version, then I can with the ball itself, I can actually do, I can check the what is that called? The detection. I can detect the proximity. So here, this is something that it hasn't changed. This is for this ball. And the reason why I put this in double quotes over here is because this represents an operator that gives you access to the object that is actually running. If you take the next class, which is the AP class, or if you go to college and take the next class that it has more advanced topics in Java, then this operator will show up. Then from this other ball, I can get all the attributes through the getter methods. Here it is. I can get the Rx for the other ball, and I'm going to call it Rx2 with the get method, and the get Y for the RY2. That's the other ball. I also need to know the radius because I have to do that calculation that we already saw in the website where I showed the geometry of it. So pay attention to how I need to explicitly bring in the name of the object to access the Rx and Ry for that object. It's not necessary, as you can see, for Rx because it's from this object. So you don't need to call a method for it because that is the instance field of this class. And here I go along to according to what we did in the geometry, which is nothing more than the Pythagorean theorem. And then once I have this distance between those two balls, now I have to also include the radius of the two balls. It all could have been in one line, but I made it in two lines because I think it's more readable. So I took from this original distance even a little bit more because I want to make sure that I include the radius. Those points, Rx and Ry, are not the points that we're looking for. They're the center of the circles, not the edges. And that's why the radius had to be included in there. And so radius is radius, Rx and Ry are all instance fields of this object. If you go to the top, right here. So anywhere in this class, you have access to that information. If something is coming in, when I say something, is if an object comes in as an argument, you need to use the object and the getter methods to get information about the instance fields of that object. Now, this is the part that I already talked a few times, in which how close do we want those balls to get together? How close do we want them together in which we can say, okay, this is it. This is actually a collision. And it all depends on so many things, right? We talk about the positions are random, the velocities are random, the radius are random. So having one particular value can be tricky. And it might work 50% of the times, 50% of the times it might not work. The balls might not actually bounce off. So to be really good at it in terms of making it realistic, we will need to use percentages. And this is not what this assignment is about. So if you get a good number of ball bouncing, I will be more than satisfied and done with. And that's how I actually have the behavior of getting those balls under that effect of bouncing. So changing the velocity, the direction for this ball, okay, I can do it, by manipulating the actual instance fields because I am inside this ball. But if I had to change, and this is optional because each of them will have that reaction anyways, but let's say you do want to manipulate it within this ball, then I will have to qualify this with the name of the object. So I can access with the getter method, the velocity and change the direction. And then I only increment the location and change the location only for this ball. But I could actually do it for the other ball too. It's up to you. And then in my particular design, I didn't care because it was going to happen anyways. So I'm going to compile this. I'm going to make it run. I don't know which one it is. Oh, it's the one with the one. And so again, all I'm looking for is to have a percentage of success that the balls, all right, when they move too slow, it's going to take forever. So I'm going to restart it again. Hopefully they have a better speed. If they don't collide soon, I'm going to restart it again. Hopefully things are moving faster. Oh my God, why are they all so slow? I can change that, but I'm just looking for one collision. There you go. That was a nice collision. So something like that will be enough to say that the code will satisfy the requirements of this assignment. Nah. Sometimes, again, they will kind of miss each other because that distance of 0.01 is relative. I'm sorry, it's not relative, it's absolute. And it doesn't make sense when there are so many other factors that are random. So just having those both. Let me see if I can make this a little bit faster, just for the fun of it. I hope it's not too fast. Let's make it 3. I don't know. Let's see. Still, it's going to get close to 0. I could really force it to be fast if I remove from the negative to the positive and eliminate anything in between the two of them, which makes it slower. I don't know. Let's see what happens. Okay, that's a little bit better, but not that much. I don't know how often they will actually, we have a success over here. There goes. And it's a nice bouncing because I handle not just one of the coordinates, I did both. Touch one more time, please. There you go. And did you see what happened, right? Something, okay, there we go. And that's because it might get trapped, but it leaves right away. So that seems to be, 0.01 seems to be a good, for the size of those balls, it seems to be a good distance. Or was it 0.01? Yes. Okay. All right. So I'm hoping that this helps. There is another way to do this, and that will be a different video. The other way is to actually the following. It will be, instead of having the ball as an input argument in the method, it will be in the constructor. So what you do is you actually you overload the constructor to have an input argument, and then you create variables over here. The only difference I can tell you is the following. If you overload the constructor with an other ball, that means that you're gonna have to have more instance fields so they can be accessed anywhere. And I don't know if it's really that practical to actually do that, because you're taking up a space. And so that means that it's not a space efficient. So this one, they're all local variables, and you only need them here. You don't need them throughout the whole class. But I know some students did use putting them in the constructor, and that's okay. I'm fine with that. But what is important again is that the instance field should be private. All right, so that's the important thing. Okay, that's it for now. I will talk about the Dutch game in a minute. How do I stop this?